Dear students, you already know about inverse trigonometric functions. In the previous class, in the previous year, first year, you studied trigonometric functions. In the second year syllabus, you studied inverse trigonometric functions by online class. But once again, I revised these inverse trigonometric functions. Uh, I will tell again the domain, range of sine inverse, cos inverse and some inverse trigonometric functions and properties of inverse trigonometric functions, and I will discuss some problems 1 mark, 2 mark and 3 marks questions. Here you face the problems on this is in this chapter is 1 mark question and 2 mark question and 3 mark question only. There is no 5 mark questions. You restrict yourself for these type of questions only. In CT questions also will ask on this chapter where problems are there. You practice yourself. First you remember all the domain and range of sine inverse functions, cos inverse, all inverse functions like sine inverse, cos inverse, tan inverse, etc. Then all properties of trigonometric functions, and again the angles sine 30, cos 30, these angles also you should know about the this formula. Then only you can solve all these problems easily. First we once again recall domain and range of the inverse trigonometric functions like functions, domain, range. First, sine inverse. Sine inverse is domain is -1 to +1. It's a closed interval. Then range is -5/2 to +5/2. It's also known as principal value branch also. You know about sine functions are not, sine inverse functions are not 1, 1 and 1, 2 functions because we restrict this to -5/2 +5/2, then only it's a 1, 1 and on 2 function, then it's an invertible, then only we write domain and range of this function. Then cos inverse, domain is again -1 to +1, it's a closed interval, then range is 0 to 5. Then cosec inverse is a function from my r -1 to +1. This is -5/2 to +5/2 -0. Here r -1 to +1 means in the real number set these are not there. Between -1 and +1, this interval is not there. In the real number set it is not there. Then range is -5/2 +5/2, but here 0 is there. -0 without 0. Then all are present in -5/2 to +5. Then sec inverse function. Here also r minus, here is open bracket, this one is, then -1 to +1 which is equal to 0 to 5 minus 5. Then tan inverse. Tan inverse is from R to minus 5 by 2 to plus 5 by 2. Then cot inverse. R from R to 0 to 5. 0 to 5. Here, sometimes ask, write the domain and range of sin inverse functions or cosec inverse function. Sometimes ask domain of the cosec inverse function. That's all. It's a 1 mark question. If they ask domain and range, you should write domain and range also. If you write domain only, you can't get the marks. Therefore, it may be 1 mark question or it may be 2 mark question also. Therefore, you should always remember all these functions of domain and range. It's sometimes asked as a principal value branch of sin inverse function. Sometimes asked like principal value branch of sin inverse function or cosec inverse function. Like also. First you here glance the bracket. Here minus 1 to plus 1, it's a closed interval. It's a closed interval means minus 1 and plus 1 also included. Here also minus 5 by 2 to plus 5 by 2, it's also a closed interval. Therefore, it's also included. Between all these are included. In the cos inverse, minus 1 to 1 is it range is 0 to 5. Then cosec inverse R minus minus 1 to plus 1. Here minus 1 and plus 1. It's a open interval. Then it's equal to range is minus 5 by 2 to plus 5 by 2 minus 0. Here second one is R minus minus 1 to plus 1. Here these two cosec inverse and sec inverse. Domain is same. Range is minus 5 by 2. Here is minus 0. Without 0, minus 5 by 2 plus 5 by 2. Then here also 0 to 5 minus 5. Here 5 minus 5. 5 is not included here in 0 to 5 by 2. Here it is minus 5 by 2. 0 to 5 between minus 5 by 2 is not included. Tan inverse R, it's the domain is R. You already know about the function is like this. Graph already you know, therefore I didn't discuss here. I only glanced the formula and find the solve the problems of inverse trigonometric functions. Tan inverse function, domain is R. From R to minus 5 by 2 to plus 5 by 2. Here also minus 5 by 2 and plus 5 by 2 are not included. Between all are included. Here cot inverse function, domain is R and range is here 0 to 5. Here also 0 and 5 are not included. Between all these are included. First you remember this one. Then we go to the properties of inverse trigonometric functions. Properties of inverse trigonometric functions. Here some properties are there. Which are the properties? You have to discuss here. Already discussed them. First type 1 is sin inverse 1 by x is equal to cosec inverse x. It's x is greater than or equal to 1 or x is less than or equal to minus 1, or x is greater than or equal to 1, or x is less than or equal to minus 1. Here this is verified. Second one, cos inverse 1 by x. You already know about it. Sin inverse is cosec inverse. Cos inverse of 1 by x is sec inverse. Sec inverse x. Here also x is greater than or equal to 1, or x is less than or equal to minus 1. Then third one is tan inverse of 1 by x. Here also tan inverse reciprocal is cot inverse of x. Here the here the restriction is x is greater than 0. X is greater than 0. There are three properties. Again, three properties are there, which is sin inverse of second type of property is sin inverse of minus 6. Sin inverse of minus 6. Here sin inverse of 1 by x is equal to cosec inverse x. Cos of inverse 1 by x is equal to sec inverse x. Then tan inverse of 1 by x is cot inverse x. Then sin inverse of minus x is equal to minus of sin inverse x. Then cos inverse of sin and cosec and tan inverse. Cosec inverse of minus x is equal to minus cosec inverse x, and tan inverse of minus x, which is equal to minus of tan inverse x. Here also x is belongs to minus 1 to plus 1, and x is belongs to here r domain. X is belongs to r, and here also mod x is greater than or equal to 1. Mod x is greater than or equal to 1. Here sin inverse of minus x is a minus sin inverse x. Cosec inverse of minus x is minus cosec inverse x. The tan inverse of minus x minus tan. But other three, which are other three? Sec inverse, cos inverse, and cot inverse. You already, it's different from this one. You already know in every case, so cos is different from sin. It always extraordinary. Therefore, here also it's different. How can you write this one? Second one. Third one, which is cos inverse of minus x. Then sec inverse of minus x. And third one is cot inverse of minus x, which is equal to 5 minus cos inverse of x. Here also 5 minus sec inverse of x. Here also 5 minus cot inverse of x. Cos inverse of minus x is equal to cos inverse of minus x is equal to 5 minus cos inverse of x. Here sin inverse of minus x equal to minus sin inverse x. Here all are common, minus is taken common. But here cos inverse of minus x equal to 5 minus cos inverse x, and sec inverse of minus x equal to 5 minus sec inverse x. Cot inverse of minus x is equal to 5 minus cos inverse x. Here, the domain is always this type of same. Here also, x is belongs to minus 1 to plus 1, and x is belongs to if mod x is greater than or equal to 1, because x is belongs to r. The same cosec and sec always mod x is greater than or equal to 1, and cos is sin is x belongs to minus 1 to plus 1, and cot is x is belongs to r. You remember two pairs: sin inverse, cos inverse, cosec inverse, sec inverse, and tan inverse and cot inverse. Here. Then other properties. Other properties are sin inverse x plus cos inverse x, which is equal to 5 by 2. Then second one is cosec inverse x plus sec inverse x, which is equal to 5 by 2. Then third one is tan inverse x plus cot inverse x, which is equal to 5 by 2. These are three. First type is sin inverse x plus cos inverse x equal to 5 by 2. Second one is cosec inverse x plus sec inverse x equal to 5 by 2. Then last one is tan inverse x plus cot inverse x equal to 5 by 2. Sometimes I have to prove this one also. Then few more type is like fourth type, fifth type. These are three. Three. Second one is these are all same, but here is minus of x is different. But here is also three also sin, cos, tan, and therefore here also 5. Here 5. Fifth one is tan inverse x plus tan inverse y, which is equal to tan inverse x plus y divided by 1 minus xy. 1 minus xy. Next, second one is tan inverse x minus tan inverse y, which is equal to tan inverse of x minus y divided by 1 plus xy. Here, in this case, xy is less than 1. Here, xy is greater than minus 1. Greater than minus 1. Because xy is less than 1, it's not different. 1 minus 1 is equal to 0. Therefore, it's not different. Here, xy is minus greater than equal to minus 1. Here also it's a 0 or imaginary number. Therefore, we restrict this one is xy is less than 1 and xy is greater than minus 1. Therefore, these are the properties of inverse trigonometric functions. You remember all these properties in your mind to solve the problems easily on inverse trigonometric functions. Sometimes ask two inverse functions to adding or subtraction. It is easy to convert the sin inverse function or cos inverse functions into tan function. It is easy to solve this formula. Other formulae are there, but you remember these properties. You can solve all the problems of problems on inverse trigonometric function. I will send you PDF this all properties and domain and range of the functions. Now I shall solve some 1 mark, 2 mark and 3 mark questions on this chart. You already know about the graph of the inverse trigonometric functions, and that's all. Many problems also discussed in the online class. You already know, but I once again recall you. Here, fifth, another type is sixth one, 2 tan eta. It is the same formula, but 2 tan inverse x. Some little bit change here. 2 tan inverse x in terms of sin inverse. Sin inverse is sin inverse 2x divided by 1 plus x square. Mod of x is less than or equal to 1. Second one is 2 tan inverse x is equal to cos inverse of 1 minus x square divided by 1 plus x square. Here also x is greater than or equal to 0. Third one is 2 tan inverse x is equal to tan inverse 2x divided by 1 minus x square. X is greater than minus 1 and less than 1. These are the 2 tan inverse x right in the sin inverse and cos inverse and tan inverse function. You already know about the tan function can be tan 2x. Tan 2a is equal to 2 tan a is equal to 2x divided by 1 plus x square. Here it is in the sin theta, we can write that one. But in this sin inverse functions already right. 2 tan inverse x equal to sin inverse of 2x divided by 1 plus x square. Here x equal to tan theta. 1 plus x square is 1 plus tan square theta is equal to sin 2 theta. Sin inverse of sin 2 theta. Therefore sin cancel, is 2 theta. Theta is equal to tan. Here also put x equal to tan theta. Then again you get cos 2 theta. Cos cancel. 2 theta is 2 tan inverse x. Here also put tan equal to. Here also you put x equal to tan theta. Then here you get tan 2 theta. Tan 2 theta is tan cancel. Tan 2 theta is equal to 2 theta. 2 theta is equal to 2 tan inverse x. You can prove these 3 properties also. Then now we will solve 1 mark question of this type. First you remember all these functions like angles, sin 0, sin, cos, tan, 0, 5 by 6, 5 by 6, 5 by 3, 5 by 2, angles. Then 5 by 4 also you can write, no? 4, 5 by 3, 5 by 2 and 5, 2, 5. All these angles you should know. Then only you can solve these problems. 0, 5 by 6, 5 by 4, 5 by 3, 5 by 2, then 5 to 5. All these angles you should know. Sine of 0 is 0, sine by 5 by 6 is 1 by 2, 5 by 4 is 1 by root 2, then it's root 3 by 2, 5 by 2 is equal to 1, pi is 0, 2 pi also 0. Cos of 0 is 1, then 1 by 2, 5 by 6 is root 3 by 2, then it's 1 by root 2, it's 1 by 2, it's 0, it's 1, it's minus 1, it's minus 1, it's plus 1. Cos phi is minus 1. Tan of 0 is 0, 5 by 6 is 1 by root 3, then 5 by 4 is 1, it is root 3, then 5 by 2 is not defined, not defined, and pi is 0 and 2 pi also 0. You remember all these angles for solve the trigonometric functions problem, and in the differentiation calculus also we should take this help. First, and again identities also, sin square x plus cos square x is equal to 1, then 1 plus cos x is equal to 2 cos square x by 2, etc. This also identities you learned in the first PU class, also remember or record here. Then I will solve some problems on this. First one, find the principal value of cos inverse of root 3 by 2. Cos inverse of root 3 by 2. Let you take cos inverse of root 3 by 2 is equal to 1. Then cos y, which is equal to root 3 by 2. Cos y is equal to root 3 by 2, which is saying that 5 by 6. Therefore, it's equal to cos 5 by 6 is equal to root 3 by 2. Therefore, y is equal to 5 by 6. Y is equal to 5 by 6. It belongs to principal value branch, which is the principal value branch of cos inverse is 0 to 5. 0 to 5. First, find the principal value of cos inverse of root 3 by 2. You take, which is equal to 1, then cos y is equal to root 3 by 2, then cos 5 by 6 equal to root 3 by 2, then y is equal to 5 by 6. But referring this table, you can write y is equal to 5 by 6. This belongs to 0 to 5. It's the principal value branch of cos inverse. Then second is tan inverse of minus root. Tan inverse of minus root 3. Here also tan inverse of, you already know, tan inverse of minus root 3 is minus tan inverse of root 3. You already know the properties of tan inverse of minus x. Tan inverse of minus x is equal to minus tan inverse x. Therefore, it is equal to minus tan inverse root 3 minus of tan inverse root 3. Root 3 value is here also we take tan minus tan inverse root 3 is equal to y. Therefore, minus y is equal to root 3 is which one? Root 3 is 5 by 3. Tan y is equal to root 3. Therefore, tan y is equal to minus tan y is 5 by 3 equal to root 3. Therefore, tan of minus 5 by 3 is equal to root 3. Therefore, y is equal to minus 5 by 3, which belongs to minus tan 5 by 3 is equal to tan of minus 5 by 3. Therefore, y is equal to minus 5 by 3 belongs to which one? The principal value branch is belongs to minus 5 by 2 to plus 5 by 2. Minus 5 by 2 to plus 5 by 2. This belongs to. You can use the properties of inverse trigonometric problem. You can solve these type problems easily. You write the principal value branch also. Next, third type question is cos inverse of minus 1 by 2. Cos inverse of minus 1 by 2. We are already know about cos inverse of minus x, which is equal to 5 minus cos inverse of x. In the properties of the inverse trigonometric functions. Therefore, cos inverse of minus 1 by 2, which is equal to 5 minus cos inverse of 1 by 2, which is equal to 5 minus cos inverse of 1 by 2, which is 5 by 3. 5 minus 5 by 3. Therefore, 3 5 minus 5 is equal to 2 5 by 3 is equal to 3 5 minus 5. Some students ask this type questions also. How can you get 2 5 by 3? Then here 5 by 3 is the fraction, denominator is 3. Therefore, 3 5 minus 5 is equal to 2 5 by 3. Then it is belongs to 0 to 5. 0 to 5. Next, let's find the value of cos inverse 1 by 2 plus 2 sin inverse 1 by 2. You already know about sin inverse x plus cos inverse x equal to 5 by 2. But here cos inverse 1 by 2 plus 2 sin inverse 1 by 2 means 2 times sin inverse 1 by 2. Therefore, we can write sin inverse 1 by 2 plus sin inverse 1 by 2 plus sin inverse 1 by 2. Here, these put the value of sin cos inverse 1 by 2 plus sin inverse 1 by 2 is equal to 5 by 2 plus sin inverse 1 by 2 is equal to 5 by 6. Therefore, 6 2 3s are 3 5 plus 5 is equal to 4 pi by 6. Therefore, 2, 3, 2 pi by 3, which is belongs here, not belongs here. 2 pi by 3 is the answer. If you given only one angle, you check it's in the principal value branch or not. In other type question will ask on this type 1 mark question. Sometimes ask domain, write the domain and range of the principal value branch of the sine inverse, cos inverse. This type question also asked in 1 mark question. Like 6-1, write the domain of f of x is equal to tan inverse x. Yeah, they ask only domain of the function. Yeah, domain of the function. Therefore, domain of the function tan inverse x. Domain of tan inverse x, which is equal to r. They sometimes ask write the principal value branch of sine inverse x. Sine inverse x, principal value branch means range of the function. Here range of the function is minus pi by 2 to plus pi by 2, or you can write like this: x is greater than or equal to minus pi by 2 and less than or equal to plus pi by 2. Because this is the closed interval. Therefore, you should write less than or equal to. Here also less than or equal to. Otherwise, it becomes open bracket. Pi by 2 and minus pi by 2 are not included. They ask only write the value of principal value branch of the sine inverse x, or sometimes ask as range of function, or sometimes ask like range and domain, or domain and range of the function. Here you should write that domain also. Domain is equal to minus 1 to plus 1. It's the domain, it's the range or principal value range of the sine inverse function. I practice only one question. You should practice all the inverse functions to write domain and range of the functions. This is the 1 mark question. So this type also asked in the question paper. Then other type is 8-1. Find the value of sine inverse of sine 3 pi by 5. All students don't do the problem, write like this: 3 pi by 5 is the answer. It's the wrong one. It's already know about sine inverse of sine is equal to 3 pi by sine inverse sine cancel. Then answer is this. But it is in the principal value branch 3 pi by 5. 3 pi by 5 is not belongs to minus pi by 2 plus pi by 2 closed interval. Because you should write sine 3 pi by 5 in interval like 180 plus theta or 180 minus theta. Sine inverse sine of 3 pi by 5, which is equal to sine inverse of sine of here 5 minus 2 pi by 5. Then you get 3 pi by 5. 5 minus 2 pi, you get 3 pi by 5. You should write the angle in terms of 180 plus theta or 180 minus theta or 2 pi plus theta or 2 pi minus theta. Then sin inverse of sin of 180 minus theta. 180 minus theta. Sin 180 minus theta is in the which column? It's 180 minus theta is sin theta. It's in the second quadrant. Second quadrant sin is positive. Therefore, it's sin theta. Sin 2 pi by 5. Therefore, sin inverse sin is cancelled. Then answer is 2 pi by 5. Once again, I repeat this question. Sin inverse of sin of 3 pi by 5. Sin inverse of, you should 3 pi by 5 in terms of 180 plus theta or 180 minus theta or 2 pi plus theta or 2 pi minus theta. Then only you can write it in the principal value range. Therefore, 3 pi by 5 minus 2 pi by 5, you get sin of 2 pi by 5. It's in the 180, sin of 180 minus theta is in the sin theta, but it is in the second quadrant, it's a positive. Therefore, sin of 2 pi by 5, therefore sin cancel, then it's equal to 2 pi by 5. Here one more problem I will discuss here. Next, ninth one. Tan inverse of tan 3 pi by 4. 3 pi by 4. Here also, you should not write tan inverse tan cancel 3 pi by 4. You should write tan inverse tan of, like this one is 5 minus 5 by 4. Then it's 4 pi minus 5 is equal to 3 pi by 4. Therefore, I write it as 5 minus 5 by 4. Then tan inverse tan 5 minus 5 by 4. Tan of 180 minus theta. Tan of 180 minus theta. Here, tan is positive. All students take coaching. I already told in the first few class. All students take coaching. Here tan is positive here. But in the 5 minus 5 by 4, it's in the second part. 180 minus theta. Tan 180 minus theta. It's tan theta. But it is in the second quadrant. It's minus 10. Therefore, minus of tan pi by 4. But tan inverse of minus tan pi by 4 is tan minus pi by 4. It belongs to open bracket minus pi by 4 to plus pi. It also belongs to minus pi by 4 to 1. Minus pi by 2 to, here also it belongs to minus pi by 2 to plus pi by 2. Here also it belongs to the principal value at minus pi by 2 to plus pi by 2. Then we discuss other problems in the next class. Thank you. ಸರ್ ಬನ್ನಿ.